Okay, let's talk about percent applications. Okay, now in the first couple of videos, or so far in this module, we've dealt with the basics of percents, finding the percent of a number, finding a percentage when the part and base are known, and then finding the base. Okay, now we're going to contextualize it a little bit more and move into more practical applications of percentages. When you're looking at these can be categorized in two main categories: percent decreases and percent increases. So I'm going to do examples of both kind of all over the place, but I mean really no matter what example you deal with, percent decreases and percent increases can be solved the same way. Okay, so when we look right here, first kind of percent decrease I want to look at is a discount. Now everyone deals with discounts in everyday life, whether you're shopping for yourself, shopping for a future business, they're rampant. Okay, so we look at this one. They said if an item has a list price of $22.50 and is being offered at a 20% discount, what is the net price? Now list price and net price, list price is just a fancy word to say original price or price before the discount's been applied. Net price, anything with the word net in it, is after percentages have been applied, after discounts have been applied, and after, in some cases sales tax has been applied. I guess if you live in Washington. If Oregon, you don't have to worry about this. But we look at this one, when you really kind of understand, think about this, what is a discount? What does a discount do? Well, a discount is a percentage off the original price. Okay, so when you look at this one, there's two different ways you can find this percent decrease. Let's do it the more classic way, and I'm going to explain this using a proportion, just because I think the proportions just kind of give a better picture. If you want to solve this algebraically, that's fine too. I'm not going to do that example because I don't want to overburden you. I want to set this up as a proportion. So we got 100%. So the list price, we know the original price is this. Okay, so remember, with all these problems, the original price always goes across from 100. So let's see, and any percent change is always based off the original price, not what it becomes where it started. So the 20% I put up here, and X is over here. So right now I'd encourage you to pause the video and kind of think about what you're about to find and what that number represents. Because so many people, they'll just solve the problem and get numbers and be like, oh, just get numbers to get numbers, and not really think about what they're doing. Anyone can get numbers to get numbers, but we need to start thinking about what we're trying to find and what it represents, especially with these contextualized problems. Because it's like, if you don't really know what you're finding, why are you even doing what you're doing? Okay, so we look at this one. We do X times 100, which gives me 100X. We do 20 times 2250. Let's see. Make sure I get that one right. I'm going to cheat and use my calculator. Let's do 20 times 2250. So that gives me 450. Let's see. So we got 450. And then to finish solving, you guessed it, divide. That's the good thing about this chapter is all the solving is pretty much the same. So, for the earlier stuff, when people are kind of wondering, like, it's all over the place, solving stays consistent in this one. So we get 450. But like I said earlier, we got the number 450, but what does this number represent? Let's think about this, okay? So 450, that can't be our net price. It's way too small, right? 450, if it's 20% discount, you're only paying 450. You're getting way more than 20% off. This 450 we found, that's the discount. Okay, that's the percent. That's what we 20% of 2250. So what we need to do, because they asked for the net price, they didn't ask for the discount. We have to take that amount and subtract it from the original price. Let's see. So we got 2250, and I minus 450 from that. Okay, so you do a quick arithmetic here. So that gives me a final net price of $18. Okay, which seems a little bit more feasible. Finding 18 when you're doing $18 when you're only getting 20% off. Okay, Now, when you look at this one, that way is all fine and dandy. If you want to do this algebraically, you could just take 0.20 and times it by 2250, get this number, and then still subtract it, whichever way you want to do. Okay, again, I'm just going to show the proportions way because I think, especially for these problems, the more organization you can have, the better off you are. Let's see. So there's another way we can do this. If you think about it, think about what we're trying to find. We're trying to find the net price, right? We're trying to find what this costs after the discount's been applied. So there's a way you can kind of get around this subtraction. So we look at this. If I set up a proportion again, if I set up my proportion as x over 2250, and this equals some percent over 100. Now, if I'm thinking, and all percent increases and decreases can be solved this way. Now, if I'm thinking if they took 20% off and it's a decrease, right, it's going down. Well, if I'm taking 20% off, that means I'm only paying 80% of full price. So if I just figure 80% instead of 20, that'll take me straight to the $18. So it's kind of a back door to get around having to do the subtraction. But if you think about it, it's really the same thing, because if you think about what each of these percents represents, 20 is the 100% full price minus the discount of 20%, which we found was 450. So 100 minus 20, that's where the 80 is coming from. So really, it's the same thing no matter which way you figure it. It's just these numbers are usually easier to figure in your head. So if I do x times 100, that'll give me 100x. Sorry for my penmanship. I'm having a rough time with the digital pen today. Let's see. So that gives me 1800 when I do 80 times 2250. Oops, forgot to put my x in there. Sloppy work. Yes, I know. The teacher should be better. Let's see. Divide both sides by 100. Some of you are probably nodding to green right now like, yep, I do not like his penmanship. And I understand it because I'm looking at it right now, and this is probably the best I could do. Okay, so let's see. So cross out the zeros. So we get 18. Okay, so two different ways of doing the same thing. When you're looking at this one, just kind of think about what the problem's asking you to do. If they're just asking you for the net price, you can go straight to what they're looking for by bypassing the subtraction here. Now, if you want to do the classic find the percent of change and either add or subtract it depending on what you're doing, that's completely fine. Okay, I just kind of want to show you different ways you can get to your answers faster without having to do a lot of extra work, right? It's that saying, work smarter, not harder. Okay, and, it's one of those things. Even if they changed it, let's give you another example here. Let's use the same price, so you can kind of get an example of that getting to the answer faster. Let's say instead of a 20% discount, what's kind of another classic discount percentage? Oops, forgot I can't erase that. Let's say instead of a 20% discount, let's say it was a 35% discount. So if I want to set this one up 100%, instead of putting 35 up here, I could put 65%. Okay, because when you're looking at that, I guess I don't need the percent sign. Okay, because when you're looking at this one, if they're taking 35% off of 2250, if I figure 65% of full price, that'll get me to the answer faster. It'll take me straight to it. So I do x times 100. That gives me 100x. 65 times 2250. I can't do that one off the top of my head. Probably should be able to, but let's see. 65 times 2250. So that gives me 1,462.5. Let's see. So that gives me 1,462.5. Okay, so now let's see. So divide 100 both sides. Divide 100. So we get x equals, that'll just move the decimal over twice, get 14.625. Now we're talking about money here, so money always round to the nearest penny. So we look at the number behind it, and then round that off. So we'll say X is about 1463. Okay, so when you look at that one, just different ways of doing it. And again, you can watch this video again and again and again until you get the step down. But the fact is, it's a percent decrease. It's not going to change. The only thing they're going to change is they're going to change this number and what percent you're dealing with. But if you think about it, this can all be lumped into the same categories of percent decrease. Is if you're decreasing something by the percentage, if you take that percent and subtract it from 100, and you're just looking for the new amount, that will give you the correct percentage to put in here so you can get straight to the answer. Okay. Now the one way they can kind of manipulate this with percent increases and decrease, and we'll look at both of them, is something like this. Okay, so we look at this example, that's at the top there. If we look at this example, they said if an item costs $37.99 and you pay $29.50, what rate of discount did you receive? Okay, so now we look at this one. Anytime they use the word rate, anytime we're talking about rates, that always means percent. Okay, so probably the thing you hear this most on is interest rate. But anytime they're talking about those, they're talking about percentages. So when we look at this one, they're trying to figure out what percent we got off. Okay, so now there's a couple ways you can do this one, but I'm going to show it one way because this is the way when I always give out this problem. This is the one way everyone always does it. Is if we set this up, we're looking for a percentage, so I automatically know X is over here. Now when you look at this one, you got to remember what's your original price and what's your new one. This is the new price. Okay, this one right here, this is the original price. Okay, so the original price always goes across from the 100. So then we'll put the $29.50 up here. Okay, so now again, cross multiply. We take 29. Oops, don't know what I just did there. One second. Technical difficulty. There we go. I got it back. Okay, so we got 29.50 times 100. That gives me 2,950. We do X times 37.99. So that gives me 37.99x. Divide both sides by 37.99. Divide this by 37.99. So we're left with X. Okay, let's see what that division gives us. Hopefully it's a friendly number. So we get 29.50 divided by 37.99. Okay, so we get kind of a crappy number there. I'm going to round it up for simplicity purposes. Actually, let's just cut it off at 77.65. So we get 77.65. So we are getting a 77.65% discount. Now, if you're looking at this, and hopefully you're kind of smirking or kind of tilting your head to the sideways, like what the heck's he's talking about. The reason I'm kind of showing this right now is because this is the mistake everybody makes. We look at this one, 77.65% discount. You look at this one, you should be calling, saying, I don't know what I'm talking about with this, because that number is way, way, way too high. Think about this practically. If the item costs $37.99 and you pay $29.50 for it, and you're getting a 77% discount, you're not getting a 77% discount. You just got taken. You look at this one, the way I know this is wrong is I look at this, I think, okay, what would roughly be a 50% discount of $37.99? I mean, you could even round it up to $38 for simplicity purposes, but a rough estimate should be somewhere around $19, even if you're getting 50% off. But if I'm getting 77% off, this number is still way too high. So what we really just found is we found the percent of full price that we paid. So if I want to find the discount price, I take 100 and I minus 77.65 from that, and that'll actually give me what I paid, which I think is 15% discount. Let me check my math on that. Let's see. Let's move this over. Oop, didn't get it. Come on. Let's move this. So let's see. 100 minus 77.65. Oops. What happened there? I think I pushed times. Minus 77.65. So we get, 22.35. I'm a little off my math there. Let's see. Apologies, but I'm human. I'm fallible like everybody else. Let's see. So we got 22.35%, which seems a more feasible for the percent of discount we're receiving. Okay, so when you look at this, again, this is what I was kind of ranting and raving about earlier, is when you look at this, I guess more ranting, I wouldn't rave about this. When you look at this one, make sure you kind of figure out what numbers you're finding and does it fit the context of the problem. And this right here does not fit the context of the problem because it's too much. And you look at this, it should be setting off alarm bells in your head, like 77% seems a little far-fetched. And that's where, you got to do a little bit extra after that. I guess the other way you could have done this problem is you could have actually figured out your discount amount, subtracted $37.99 and $29.50, and then that number you got, put it over $37.99, and that would have taken you straight to the 22.35%. Okay, but either way you do it, I always show this way because this is the way almost everybody sets it up. Pun intended, like 95% of people set it up this way. But just remember, when you look at this, try to have a reasonable answer, a reasonable expectation in your mind what the answer should be. And this just does not make sense. Okay, we don't want to be in the business of getting numbers just to get numbers. We want to be thinking, does this number make sense? Does it fit the context of the problem? Okay, so in the next video, we're going to look at percent increases and different versions of those.